Welcome to my solution of the linked queue practice question. So my class is a linked implementation of the queue interface. Author. So now public class linked queue implements the queue interface. And so in this particular version we have a private linked node that points to the front of the queue, private linked node that points to the rear of the queue. And we use the rear to give us the big O1 insertion at the end to make it more efficient. Otherwise we'd have to traverse the list every time to get to the thing. And private int size. And we're supposed to implement the poll method, which removes the head of the queue or returns null if the queue is empty. At return, the head of the queue. So public poll. So what do we do first? So if front is null, or which means that there's no, our queue is empty, or I could also alternatively say if size equals 0. Right. Either case, the queue is empty, so we return null. Now we want to remember the value because we're removing something from the head of the queue, so we just want to return value equals front.data. And now we want to remove that first item from the queue, so front equals front.next. We need to decrement the size because we've just removed something from the queue. And now we return. And so again, the big O for the poll is 1. Because we don't do any looping, we just do constant expressions, and that's all we do. And notice again, this linked version is somewhat simpler because we don't have to fool around with indexes into the array. We just keep track of the pointers into our linked structure. So is it easier or better than the array implementation? If you like linked structures, this is an easier way, potentially using up less space because you only store the items in the queue instead of having the empty space in the array. But just another way of doing a queue. And both of these implementations have the same big O for the poll method because we, again, in the circular array queue, we would just grab the item at the front and increment the front index, mod it by the size of the array to make sure it goes around the corner. And in this case, we just keep the front. It's just a linked list. We're just removing something off the front of the linked list. If tail ends up pointing to front, then we have a size of 1. And then if we remove that, we would probably want to check to see if size is equal to 0. We want to set up the we want to reset tail, or excuse me, rear should equal null. Because front will be set to null here, and then if size is null, rear will still be pointing to that old node that's been removed, so we want to reset that to point to null. And there we go.